We're going to give people a couple minutes to show up, given the hour. Oh. Okay. Oh. Great. Guess I gotta do it again. I'd appreciate it if it stopped doing that. Maybe I should. Should I wire in so it stops doing that? Let's see.
Oh no.
Yep. All right, we're going to get going. So, welcome to the quick working group meeting at IETF115. If this is not where you intended to be, you're welcome to stay, but you can also find where you were meant to be instead. So some things that everyone's probably seen already. The note well is the list of things that we all operate under as part of the IETF. If you have not noted it already, please do so. So some other tips that you may not have seen yet. So for in-person participants, make sure to use Meet Echo in order to, on your mobile device or from your laptop, to get into the queue. And for remote participants, make sure, the typical audio video stuff, mute yourself if you're not talking, otherwise we will mute you. And also, please use a headset if you are talking because audio can be challenging. So Administrivia, do we have anybody that is willing to take notes? Robin is not here at the moment, and Robin is usually the one who volunteers. So is there any other brave and hopeful souls? It would be really nice. Anybody? Okay. Martin needs a backup because he will be one of the people presenting. Is anyone willing to do that while Martin is presenting? Eric, thank you. We appreciate it so much. Blue sheets are done via Meet Echo these days. We truly live in the future. And chat is Meet Echo. And we will be running the queue. And again, please do get into the queue, or at least attempt to get in the queue locally via the Meet Echo interface. So agenda. So we're going to have very brief chair updates. Then we're going to get into our working group items, which consist of multipath, acknowledgement frequency, QLog, and quick LB. And then as time permits after that, we will be talking about, and Ian is laughing at the agenda, which we will talk about in a second. After that, we will get to reliable quick stream resets and quick FEC, assuming we have time, which we may. Does anybody want to bash this agenda? Martin.
I just want to use the opportunity to shill for the congestion control working group side meeting that will occur at 5 p.m. on Thursday, since that seems relevant to people in this room. Thank you.
Yes, I believe it is relevant. Anyone who is interested should attend. Is there any other agenda bashing? Ian, I think you may want to say something.
I do not have slides prepared, so unless Jana has slides prepared, I don't know exactly what we're going to speak about. I think I apologize. I dropped.
It's all right. That's very useful bashing. Saves us and since Jana's not here, we will just kind of play that by ear and maybe.
You have 40 minutes to write slides, Ian.
Is there any other bashing that is maybe people want to do about this agenda? Okay, and with that, I think, Quentin, are you ready to present? Oh, we have not finished. Wait. Oh, we have one more slide. Sorry, I forgot about our updates, our share updates, which will be very brief. So applicability and manageability, they are RFCs, yay. Quick brief bit, also an RFC. So this is forward progress. And then version negotiation V2, not quite RFCs, but have made it through the ISG. So thank you everyone for your contributions to these documents and the continued forward progress of the working group. And
I was going to put one more bullet point on this slide, which I forgot to do. If you recall, a while back, we had the quick LB draft that contained two concepts, and a little while ago, we split those drafts off. So we have quick LB focused on load balancing, and we have the retry offload draft. We've been speaking to people in back channels just to understand the implementer interest in that proposal, and we're not seeing much, or if any, right now. It seems like a decent piece of work is what we're hearing, but our plan is to effectively put that one in the deep freeze for a while. So just look out for updates on the data tracker. If you have any implementer interest or any questions there, come and ask us on the list. But otherwise, that's what we plan to do. So yes, please come up, Quentin.
well, actually, I forgot that I had another slide, even though I made these today. So just another thing, in case anyone was aware, Mask is happening on Wednesday. That's relevant to many people's interests. And of course, Media over Quick, the new hotness with Quick, is happening Thursday, session 1. So if you're interested in that, please do show up. And now, no,
Sorry. Yep.
this is great.
I've been busy. I've got excuses, but no excuses. I wanted to add these, like they're normal. People who come to the IETF are familiar with these working groups. We have separate working groups for good reasons, but what some of them might be touching on are things like extensions or inputs and use cases into things that those groups would like from the Quick Transport Protocol. So if you don't normally attend those groups, it might be within your interest to go and see how people are using Quick, and maybe the sorts of transport features that they would like to bring back to us, which is within our charter. So is that the final slide? Okay, we're done. Let's get out of the way.
Now Quentin can take it away.
All right, so I'm Quentin de Koning, and on behalf of the Multipass Quick Draft authors, I will present you the updates since the last IETF. So next slide. And actually, the updates since the last IETF are quite small. It's minor changes mostly, and mostly editorial. So the two first bullet points, I will discuss them a little more in the coming slides. The third point is about removing an error code point that was not useful because it was an error due to a wrong transport parameter value. So we can just say it's an invalid transport parameter code point. And so we can get rid of useless error code. And there are additional editorial PR that were merged, but these are mostly adding an entry to a table, fixing some commas and so on. So nothing very really interesting to discuss here. So next slide. So one of the contributions since the last time is adding some consideration for single packet number space to do some RTT measurements. So the issue that we have with single packet number space with the recovery algorithm that as defined by Quick Recovery is that some paths RTT might never get updated because ACK frame may come from other parts, and some paths might just not get any RTT updates. And you only update your RTT sample only if the largest acknowledged field increase, and sometimes your RTT actually correspond to the sum of two different one-way delays, so you don't have a clear view of the RTT. And so the Alibaba folks made some experiments, and so they're really conclusive, and basically their solution are in 2 points. Either you use the timestamp option as defined by the Christian draft, or you adopt specific heuristics at both the sender and the receiver of the ACK. So at the sender of the ACK, you write path specific largest acknowledge, and at the receiver side, you update, you consider RTT sample when you increase the largest acknowledge. And so maybe Yunfei want to add something?
Oh, yes. I want to add a few points about our experiment. I think in our experiment, one goal we try to achieve is to get the single packet number space as accurate for RTT measurement as multiple packet number space. But in doing so, we in the end made some trade-offs. So for example, as multipass QUIC allows ACK to be returned from either passes, but in order to get more RTT measurement, we end up having the ACK enlisted and returned from the same pass. And also, we also modify the largest acknowledgement field in the ACK MP field, which is not standard. But so we're wondering if anyone has a better solution to get more RTT measurement. Please do let us know.
Martin, did you want to?
Martin Duke, Google. Am I misremembering? Didn't we get rid of single packet number space in last time?
So nearly, but we are going to discuss that in the remaining of my slides. We are going to discuss if we are going to keep single packet number space. So currently, we have a unified solution where if you are using non-zero connection IDs, you are using multiple packet number space. But if you use zero-length connection IDs, then you use single packet number space and with some considerations. And yeah, so for that case, actually, this consideration might be useful. But the point that we will discuss later is, are we going to keep single packet number space at all?
I thought we had murdered it last time, but okay. Thanks.
Quentin, do you have a slide that talks about the single versus multiple? Because that may be, maybe we should just talk about that now. Oh yes, there's one. This one. Reminder.
Yeah, I can quickly.
Ian, did you want to talk to the previous thing or to this more generally?
I wanted to say exactly what you just said, because I would rather if we're going to ditch single packet number space, then maybe we can
Yeah. So why don't we talk about that now?
We can talk about that now. So the difference between single packet number space and multiple packet number space is that in single packet number space, you have multiple paths, and you have the application data packet number space, and you spread packet numbers across the path, but you keep the same sequence. So for instance, you can send one on one path, then number two on a second path, number three on a different path, and so on. While in multiple packet number space, you have number space for each path. So you have number one for a given path, and you have number one for a different path. And to acknowledge packets from different paths, we have to include an additional frame, which is called ACK-MP, which includes the path identifier you want to acknowledge. So in the single packet number space, you acknowledge packet with the regular ACK frame, while in multiple packet number space, you use the ACK-MP frame to acknowledge packet from different paths. So,
do you want the next slides about this, or is that?
Yeah. So that's basically what I just said about the current state. So the current state is that currently we have mandatory support for multiple packet number space when we have non-zero length connection IDs, and we have optional support for zero length connection IDs, which means you are using single packet number space, and you have to adapt different elements in congestion control, RTT, like the consideration we just discussed before. And if a host does not want to support a single packet number space, it just has to restrict to sending only on one path. But it has the sending host that to enforce that it can only send on one path. Yeah. So this is one of the issue actually we wanted to raise. So do we want to keep a single packet number space? So we made some evaluation reports, both from Alibaba and from myself. And we had a few key findings. So the first one is that given the RTT change heuristic we just described before, we can have RTT samples which are quite correct. But even without losses, we noticed that in single packet number space, you can have huge hack holes. And if you limit the number of hack range you advertise in hack frames, actually, you can decrease the single packet number space performance. Also, as a receiver, typically, you keep a lowest packet number that you consider to keep some state to track some lost packets, and lower packet number space than the one that you keep, you consider that it's duplicate, and so you consider them as being lost. And if you do not change that heuristic at the receiver side when doing single packet number space, what happens is that you might miss valid packets, and so you might just drop incoming packets at the receiver side. And overall, all these points that we just described is that on large transfer, typically the performance of single packet number space is lower than multiple packet number space because you have acknowledgement issues and you have spurious losses. So that comes to my first question. Next slide. So the first question is, do we have now any strong use case that requires zero-line connection IDs with multipass in the basic draft? Kazuo?
Kazuo, firstly, so I actually have an argument against having any use case for this. And that is the privacy concern that we have in RFC 9000, which says that an endpoint should not initiate migration with a peer that has requested a zero-length connection ID, because traffic over the new path might be trivially linkable to traffic over the old one. I think this might apply to multipath QUIC using zero connection ID. And if that's the case, I don't think we are even allowed to encourage, or I mean, if we are to have this support for zero-length CID in multipath QUIC, we should say that it should not be used because that's what QUIC beyond says.
Okay.
Mia Kuhlevin. So you're citing text from the security section, right? Secure consent. Okay, so I did look up this text because I was trying to figure out how to get rid of single packet number space, right? And I was looking up the part about migration. So the RFC 9000 actually does allow migration without connection ID. It's kind of you may thing, right? I mean, there is a secure consideration, but to be in line with RFC 3000, kind of like we should probably allow it because that's what the base spec is, and that's a decision to take if we can actually restrict this more than it's currently restricted in the base spec.
Kazuhoku, I think that's a fair argument, though. I think the question here is if we want to spend our effort specifying something that we would say that should not be used.
Maybe go to the next slide. But the thing that would actually make this spec very easy would be to say it must not be used, and that's actually something I would like to figure out today.
Yeah. So actually, it comes to the second question that we wanted to discuss is, should we keep support for single packet number space at all in the base draft? So we have two kinds of solution. The first one is to keep the draft as it. So we just keep single packet number space support for zero-line connection ID. Otherwise, we use multiple packet number space for non-zero-line connection IDs. And the other solution is just to say, just drop single packet number space, and we keep only multiple packet number space solution. And with that variant, we have two sub-variants. The first one, we can just work with the initial path that may work with zero-line connection IDs. But if you want to use additional paths, you have to have non-zero-line connection IDs that you can provide afterwards. Or the other solution is just to say we drop support for zero-line connection IDs at all, and we may write an extension draft later if we want to support that use case. And so the question is, what should we do?
Does anyone want to? Oh, okay, we've got Eric.
Eric Kinnear, Apple. So are there any people who have a quick implementation who would find it unpalatable to implement multipath because of removal of support for zero-link CIDs? Like, is there anybody who's saying, hey, we really need zero-link CIDs and therefore I will not do multipath? In that case, it seems like removing it, and then we can always choose to leave the door as open as we want for an extension when somebody comes up with a legitimate use case. But if it's not going to prevent anybody from doing this.
Maria.
Yeah, to make this more concrete, so the way also I think we could remove a lot of text from this draft would be to say, if in the handshake multipath is requested and there is no connection ID in the handshake packets, then you must not negotiate multipath support, right? Like only if there's a connection ID for the first pass, then you're allowed to do multipath support or negotiate it even, right? So that would be kind of the thing that would be the easiest thing. But like in line with the current draft, like you could say, I have implemented multipass and I'm willing to use it, but even if you don't have a connection ID on the first pass, because like I don't even know if you're using multiple passes later on or whatever, I'm still willing to tell you that I'm multipass capable, and then we figure out what to do later. And that is even more complicated because in that case, you can use the first path without a connection ID, so that might actually enable some use case, I don't know. And then you have to use the connection ID on the following passes. That's all fine. But then you also have to kind of support migration for the first path without connection ID to a different path. Or you effectively leave the door open even for like, if you receive a packet without a connection ID on a different path, you can still decide to actually try to decrypt it and use it and send an ACK or not or whatever. You leave the door much more open about it, and people could just like do things with it. But that also makes the draft a little bit more complicated.
Does anyone believe that we are not at a place to pretend? Oh, Alessandro, you want to talk?
Alessandro Gadini, Cloudflare. So as we were talking about in the last meeting, as you know, someone who's actually looking into implementing and deploying multipath, right now, I don't think we are even going to support zero-line connection IDs like at all. So if it's, I guess if there's someone who wants to have that supported, like they should probably speak up now, because I think most deployments are not going to support this at all. And it's probably better to just remove the support for single packet number spaces, or even like completely for zero-line CIDs from the draft.
Okay.
So would the authors be happy with a potential poll asking the question, should we remove zero-length CID / a single packet number space from the current document? Or is that not sufficiently clear? Is that a good question to ask the room? Yes?
Yeah, just a point is that as an editor, the document would be much simpler and much more readable if we keep only one variant, because currently we have a lot of points where if you are using multiple packet number space, do that. If you are using single packet number space, do that. So as an editor, it is simple if we only keep one variant.
Alex?
Hi, Alex Strohowski, Google. Just over lunch, I was discussing with David Skenazy a potential alternative design that was sort of similar to multiple packet number spaces. And I was wondering if it had been considered, which is what if we did multiple quick connections, possibly steered to the same server using the encrypted connection ID draft that Martin Duke and co are working on, and we just bonded the connections together. Because in many ways, that's really similar to what we're doing. And I feel like we could accomplish a lot of the same properties without adding explicit support for multipath to the individual connections. Sorry, Miria is asking if we can explain a little bit more. So basically what I'm thinking is, it looks like we have two ways of doing this at the very least. One of which is we can add this support intrinsically into each individual connection, or we could bond multiple connections together that have their own individual paths. And I'm mostly just asking if we had considered those trade-offs, because it seems like we're making a lot of choices right now, adding complexity into a connection that I wonder if it could be handled at a different level.
Eric, did you want to speak to that point, or?
Yeah. So Eric Kinnear, Apple. It's certainly worth talking about cool stuff. So I don't want to like gut feeling reject things, but one of the important parts about multipath, I think, for us is the ability to have a stream that is split across multiple paths. And so once you lose the like, this is a logical byte stream that is going to be delivered in order. Now, again, in order is interesting when they're coming in from different paths, but part of the point is to be able to take being partway through some stream and have the rest of the stream go over a different path. If you start trying to bond different quick connections, I think you lose that property.
Yes, it would definitely have to be implemented at a different level.
Yeah.
But I guess that's effectively the question I'm asking is, do we want an abstraction inside of a quick connection to deliver this, or do we want an abstraction on top of multiple quick connections to deliver this? Because I feel like you can get the same effective property, but it makes the application look the same way, but you don't necessarily have it be in the quick code. And this might be a way of achieving layering, which could potentially be better.
Ian Sweat, Google. Can I go now? Or, okay. I definitely discussed this at some point with someone, and I have no idea who. But I think the key. So number one, I think it's a very good idea to really consider and like walk through. Basically, what I think it requires is like a really clean split between what I might call the connection layer, which is like loss recovery, loss detection, congestion control, the crypto handshake, like, and all that stuff, and the session layer, which sits on top of it, which is like streams, reliability, and all of these things. I think it's a very doable concept, but I think in order to get good consideration, probably something should happen. Like Alex and I should sit down for 3 hours and like write up a very like short draft about like sketching out how it might work, and then you can all like basically either say it like seems like a reasonable design, or like this is like not going to work because it like has all these holes. Does that seem like a reasonable way forward?
I think there's always cool stuff you can do with Quick. I don't want to limit the art of the possible and people's imaginations. So if that's something you want to go away and write up and maybe email to the list, feel free to do that. I would like to remind people that we did spend a long time to get to the point where we were comfortable with adopting multipath Quick and the feature set that it would provide to people, like stream related that Eric just mentioned. So, you know, I don't want us to, we're trying to hone down from 2 options to 1 right now. And this sounds like we're adding a third. Maybe I'm reading wrong, but like it's adding complexity to the question. And my concern is that we halt progress while we wait to figure out some more complex things.
I would argue we should kill the existing single packet number space design regardless today. Like, I don't think that's on the table from my perspective. Like, I think it's either like we either do multiple packet number space, or like, you know, in a week or a few weeks, we decide that we like this other thing better. I don't think we should keep single.
Okay, that's good input. I would just say go away and work on your thing, and if you come back with something, we can review at that time. But for the editors of multipath Quick, take the outputs from this meeting and continue working as hard as you've been doing. Thanks. We have more people in the queue.
Yes, we do. Tommy, do you still want to talk to that?
I would, yes. Hello, everyone. So first, to the question on the slide, I agree with pretty much everyone else that's spoken so far to say that we should probably just keep the multiple packet number space and kill the single. That is fine. Regarding this other direction, I think, if you want to go off and write something up and have a new draft that's about bonded quick connections that you do at a application level, and if you have use cases for it, great. Go ahead and do that. I do not think that is multipath quick. That's a separate thing. And certainly there are applications that may not want to use multipath quick, but there are applications that want to use it at a transport level. And I don't think we should confuse those things. I think it's fine to have multiple techniques that can get use of different paths and different available networks, but having a transport level function for this that is equivalent to MPTCP in its capabilities, but also allows you to have different streams scheduled over it is highly useful. And the work that's done on this draft is extremely good and a very good basis for things. That shouldn't prevent other innovations around stream bonding at a higher level. But I would strongly object to having another design be put forward to replace in this work and then stop working on this, because this is an important basis for work.
Christian?
Good morning. Yes, I mean, we did in fact look at that very early in the discussion of quick multipass. I mean, there was a lot of discussion, and it was, hey, we can do a lot of the scenarios by having multiple connections instead of just one. We never did the have multiple connection and bring them together because I think that brings all the complexity of multipass, the practical complexity of implementation, and then add some, plus you have to do multiple complete handshakes and all that kind of thing. So, I mean, I'm all for letting 100 flower bloom and have someone study that if they want to, but I would certainly not like stopping the current discussion. As for the question on the screen, I support the consensus of the quick authors that we should basically keep the draft simple and just say, hey, we do not support zero length connection ID if we do multipass. And that makes the draft simpler. And we can always, I mean, we have a lot of old draft and current draft, and we have material if we want to revive that ID as another discussion. I mean, it's fine.
Ted?
Ted Hardy, mock enthusiast. And I just want to point out, I think I very much agree with what Eric was saying before about the ability to have a stream be across two different paths being an important use case. And I think it's particularly an important use case for some of the media over quick work. So if that's something that the group is going to continue along that path and possibly add another path for this bonded thing, then that seems fine. See what the bonded people come up with and consider it separately. But I think it would be very useful to consider separately. Media over quick is not yet talking about multipath, but I think its presumptions about what it's going to get from multipath quick are very much based on an idea that it's presenting you kind of a single interface rather than a bonded one. Thank you.
Faye?
Yeah, so at the beginning, we have also considered about the connection bounding. But I think the benefit of multipath is not just about bandwidth aggregation. It's also about the ability to schedule at the packet level so that you can adapt to network variation very, very quickly. That's one of the big advantages that the current draft offers you. So this is my first comment. The second comment is that for single packet number space versus multiple packet number space. So at Alibaba, our use cases, we use multiple packet number space. So I think if we just keep one, the multiple packet number space, it will definitely simplify things a lot.
Maria?
Yeah, I went last in the queue because I just want to check quickly to wrap up this conversation. So like, I think there's broad support to get rid of single packet number space. Just to confirm that this means what we will say is a server must not negotiate multipath support if there's no connection ID in the initial packet, right? So that just everybody has the same understanding.
Yes, and I think we will do a quick poll just to confirm what seems to be broadly supported, just in case there's anybody who's holding back their disagreement. So the question here is basically what Myriad is going to say, which is, should we remove zero length connection IDs from the current document? So raise your hand if you think that is true, or vote in I guess virtual raise your hand. Okay, so that is fairly convincing, I would say, in terms of the support for removing. There was someone in the queue, but they've dropped. So I think we will.
Sorry, can you just read the results for the minutes and for the?
Yeah. Yeah.
Yep. So we in the MeetEcho attendance, we have 165 people reported. We reported from the show of hands question, should we remove zero length SIDS / SPNS from the current document? 53 people raised their hand. 2 people did not raise their hand. Sorry, just to preempt what Matt's going to say here, because we're on the same wavelength. We'll take this input. I think the answer is pretty clear, but we'll take this to the list to confirm consensus. So do look out for that email post this meeting.
Mary, do you want to say something else?
Yeah, I just want to ask if those 2 people actually, why they raised their hand for not removing it, if they have a use case or whatever. If they don't want to speak up, they can also reach out to the office.
Yes, that is always. Please feel free to do so with whatever venue you see appropriate. Okay. So going back to the slides. Oops. I don't see anyone in the queue currently. Yeah, what slide would you like to be on? Oh, now we have people in the queue. So does anybody actually want to be in the queue right now? Because we see a lot of people coming in and out, which is a little bit strange. So commit. Okay, what slide would you like to continue from at this point?
I still have only 2 slides, so slide 4.
Okay, going backwards.
Okay, so just talking about the updates, coming back from the update we made in the last IETF. There were some willingness from implementers to know how they should map the keep alive mechanism of single pass quick to multiple pass. And so we added some text in the implementation consideration saying that in the end, the scheduling you want to apply to keep your keep alive will depend on the application that you will be serving. And so the application should just define how we should perform keep alive. And then we can move to slide 6. Okay.
Sorry, before we get too far off of keep alive, is it worth having text in there that states that essentially allows either, you end up with the minimum of either side's choices, right, for any path? Is that something that we want to explicitly state to make it clear that between you and whoever you're talking to, if I decide path 1, 2, and 3 needs to stay alive, and the person I'm talking to wants 4, 5, and 6, which is an awful lot of paths, but whatever, you end up with all 6 at whatever the minimum interval from either side is.
Yeah, you just have to define something, and depends on what you
like. As long as we're all comfortable with that, then
yeah, it's just that.
So effectively, this is an interface question, right? It's like how you, like if your interface said just send keep alives and doesn't give you any guidance, then I don't know what you do. If the interface says send keep alives on class X, you know, that it's an application decision. But like I'm not, I mean, like for the term keep alive, I find this actually really confusing because keep alive means like I still have a connection to the other endpoint on one path, right? So I kind of need to ping all the passes to make sure that like there's at least one path alive. And I would actually like to define this more strictly rather than leaving it as an interface question, to be honest, because that's for me how keep alives are defined. I don't know. You're nodding.
I can stand up and nod more verbally.
So, okay, what I'm so currently we say this is not our business, it's an interface question, but we could also say if you want to keep alive, you have to ping off all paths.
I think it's fine to say that it's not our business here, and as we actually get more experience with it, we'll probably bring an extension that introduces some more explicit signaling around, hey, I think that path 2 is the one I really want us to, you know, care about the most and just ping on that one or whatever. Like we've also got a couple of cases where we'd like to let most all the paths go away and be able to reestablish them later. So it seems like there's a lot to unpack here, and I don't know that it needs to get in the way of what we're trying to do, but I also don't think you need to say like ping them all the time, every time, forever.
I mean, yeah, probably it's a good idea to leave it open, but I'm wondering if there's any use case where you would actually say, please only ping path 2. Because usually the use case is please figure out if there's connectivity, right?
Jana, you want to?
You got Michael in line.
Oh, I think he's trying. Michael, are you trying? I don't know what you're trying to grant slides, which I think is probably not what you want to be doing right now. So, Jana.
Jana Iyengar Fastly. So to the question of, I think it's very tightly tied to the question of scheduling and what paths do you want to use? When do you want to use them? What is the purpose of the multiple paths? And that is really an application and context question. In this particular case, just because you have multiple, let's say, for example, you have a cellular and a Wi-Fi path. If you do not actually want to keep pinging on the cellular path because the cost to radio is too high, you may choose not to do that. That is very context specific. So it's not just application, but it's context as well.
Okay, that's the point, but it's like, it's also strange to me that you ping on one path and then you don't get a ping reply and you have like 3 more passes that you didn't even try and you close the connection. That's what you want.
Maybe so.
Okay.
I mean, I think that's entirely reasonable, right? It depends on what the application defines as semantics for the paths.
Could I ask the people that were involved in this discussion to maybe reflect some of that on the issues so that that is captured? Lars.
Hey, Lars, and please tell me if this is taking us into the weeds too much. So one of the things with QUIC, right, that I really liked is that you don't need keep alive as much as you think you do because we have zero RTT resumption, right? And there's a consideration here that if you're coming from like old style protocols where you needed to keep the thing alive because otherwise we had this gazillion overhead handshake again, you don't have that with QUIC, right? So maybe we should sort of remind people that it's actually not terrible if you just let paths die and even the connection die because you can get it back very fast. Right, so this sort of optimizing keep alive sort of feels wrong because we have zero RTT resume.
Jana, I assume you're trying to get back in the queue.
There we go. Yeah, so what Lars said is actually really important here as well. In this particular case, now I haven't looked at the multipath draft recently, so you'll have to tell me when I'm wrong about this. If you drop the path, is there actually a latency penalty to be able to join or add a path back up?
Sorry?
Is there a latency penalty to creating a new path?
You have to do path validation.
That's fine. So I think, yeah, I mean, if the IP address is already in use, presumably path validation would not be required from the server's point of view. So I think that in this particular case, yeah, you should absolutely think about keep alive as not necessary, but useful occasionally.
Okay.
Christian?
Say pretty much what Jana says. I mean, it's silly to believe that A, we will need to keep alive forever, and that B, we know today what implementers will learn tomorrow. I mean, we have a tendency in some drafts to be very, very specific about what implementers will do. I would much rather leave the current text as is and say, hey, you're making decisions, make them.
Miria?
I just want to clarify or ask, I don't think we're currently saying that you can actually reopen a path without path validation if you have used it previously, because we don't really hold state about what passes were there. So we always require path validation. Is that a requirement that you know?
Yunfei?
Oh, I just want to comment. There is also another penalty if you reopen the path. That's the congestion window, right? It needs to be reset. And also, I think the reason why we have this text here, because we in our deployment experience, we do see the problem if you don't keep sending keep pass alive ping, because for the multipath sometimes if you use main RTT scheduler, you keep sending packets through the shortest path, while the other path remains idle for some time. And after a while, if you want to use that path, you send packet on that path and you find some black hole issue. So that's what we have observed in our experiments. So that's why I think we want to add some text here.
Jana?
Jana Ingar, on the question about revalidating old paths, that's already in the core spec. We explicitly allow for endpoints to remember state and to do stuff when useful.
Eric?
I would suggest that we move on to the next slide.
It sounds like there's a lot of thoughts on this, and so I would encourage people that have opinions on this to either somebody take it to the list or perhaps comment, do some hashing out on the issues involved, because I don't think any of this discussion has been reflected there.
Yeah.
No, we can open a new issue, but I want to say we explicitly don't have this. We always require path validation, because here it's different, because you always have a working path. This is only a second path, right? So like it's not seen as this kind of urgency that you can just switch over or have to switch over to a new path because you have an existing path. So we always require path validation.
I think it might be a good time for a couple of us to go have lunch at some point.
Yeah, I think.
No, I mean, if you think that's a requirement, then actually open an issue.
There's a whole bunch of stuff to unpack there around both bringing up the congestion window. Like if I've got a path that's been idle enough that I needed keep alives, we've probably dropped the window already anyway. And you can actually use application data in your path validation to help bring the window up sooner, and use that to prime it. You can even do that with migration without multipath, just without application data. It has to be padding. So like, let's grab a couple of folks and make sure we unpack all of that, but I don't know that we're going to solve it right now.
Yeah, but it doesn't have to be in this draft, actually. I'm just reflecting what's in this draft currently.
I agree with, I'm happy to be in a separate space to discuss this. However, I want to note that there are things like this which should basically be the same considerations as we did for connection migration. We shouldn't reinvent the draft, the RFC language here in this draft. I would like us to reuse the work that we already did for the RFC here.
Okay. I think we can move on from this for now, and perhaps we need a new issue, possibly a mailing list discussion, and also people talking here while they can. What do you want to? Which slide is it? 6? Jumping around.
Okay, so about one of the remaining issues that we recently found is, what about if you receive a pass abandon with an unknown pass identifier? And when this can arise is with the following situation where you have a host that want to close a pass, and with the pass abandon, you can identify the pass with the connection ID used by the peer to send packets. So the destination connection ID used by the peer. And so you provide the sequence number in the pass abandon, but before it reaches the other side, it might rotate its connection ID and send, okay, I retard the connection ID. And so it forgets everything about that connection ID. And so, which means that the receiver cannot map the ID anymore to a pass. And so we have an issue here. So the current proposal is just to say that the sender of the retire connection ID. So when you retire a connection ID, you just keep for a while some state saying that that ID was mapped to that given path. And so that even if you have retired the ID, you can process the path abandon. And if you cannot process the path ID that you have in the path abandon, the other solution is just to say, okay, I cannot no, I don't know on which path you want to close, so let's close the connection because you can have a path with a middle open state. And so this is probably not what we want to have on the connection. Miria?
So I should probably know this as an author, but I was confused about this before. Why do we change the path ID when we change the connection ID?
You may change the connection ID because
Yeah, you can change
yeah,
the connection
you
ID,
want
but you
to
don't
keep
have to change the path.
a fixed path ID. Yeah, okay. Currently, the path ID is the connection ID sequence number. If we want to have a fixed path ID,
So we don't say something in the draft explicitly about what happens when you change the connection ID, if you update or not. You were assuming we're updating it, and like that wasn't clear to me. And like if we don't update it, we don't have this problem.
yeah. But if we want to rotate and update, yeah, we have to add some consideration with that. Yeah.
So, but there's no good reason why we change it. We could just keep it, right?
The reason you might just want to rotate because for privacy reason, but
Yeah,
except for that,
the connection ID, yes, but like why we change the internal management of the path ID, there's no reason for it.
Yeah.
Okay, so that might be another solution.
Christian?
Solution. I mean, if you think that this kind of race condition happens rarely, the simpler solution is to say, okay, the host will just resend a pass abandon with a new ID. Because pass abandon is really an optimization. It says, I don't want to receive data on that particular 5 tuple. And so if you want to not receive it and you send a message and you see that the connection has changed or whatever, but basically you keep receiving data because the peer has not in fact abandoned the path, then at that point you resend one or you junk the connection. But it's really simple. I mean, you don't have to do anything in particular.
Okay.
Martin?
Yeah. So Martin Thompson, I've always been a little bit uncertain about this whole idea of taking the sequence number for the connection IDs and using them to identify paths. It seems like if either endpoint changes their mind about which connection ID they want to use, then you're in a situation where you're effectively changing the identifier for the path that's involved. And so for something like path abandonment, you can abandon, well, effectively every connection ID that you generates a new path identifier. It's asymmetric. Each side has their own identifier for these things, and potentially one or other can have multiple identifiers for the same path because they can choose to use multiple connection IDs. So I think Miri is probably right here. You've been economizing in terms of how you do this identification because you do really want to use the connection ID as a proxy for this. But it seems to me like there is an extra level of indirection necessary in order to get something like path abandon to work. Because when you say that I'm abandoning my path number 7, you might have also path number 11 that is really the same path, and the other side has 4 and 5, which are the reciprocal flows on that same path. And they have no idea of knowing really that that's what you're referring to at this point, because ultimately that's just the way the protocol works. So it seems to me like there's like a bigger problem here.
Yeah, no, I think it's doable. We have to think about that, but I think it's a good idea. We should think about that. Yeah.
Christian?
Yeah, I mean, let's remember why we did this linkage between connection ID and pass ID. The reason why is that we want to have AED encryption And AED encryption relies on nonces, and the nonce is the sequence number. And so if we do that, we need to make sure that the same sequence number and pass ID never happen at the same time. That means that the the receiver has to bring the pass ID inside the encryption initialization, inside the effectively inside the sequence number of the pass. And so that means that the receiver only sees the connection ID to do that. So the receiver has to have an immediate link from the connection ID to the encryption context. And the encryption context effectively defines that for the pass. So if you break that linkage, then you have to have all the relation with the encryption. It's not just about saving an ID, it's about making it simple when you receive a packet to understand which encryption header it uses, which sequence number space and things like that. So if you break that, you end up having to redo your encryption implementation.
Eric?
So I was just thinking about what you would do if you were doing some of the cooler schemes that Kazuho had previously described of things like, I'd like to send a different connection ID for every packet. And if I'm doing that, and that requires bringing up and down a new path, or having each side cycle what they think of as the path, if we're going to do that on a per packet basis, it seems not great.
Martin first.
Either I'm confused or this is confused, and it's probably the former, but humor me. So and why not both? So are paths unidirectional?
Connection ID is unidirectional, yeah. But the path ID is unidirectional as well.
Okay.
But currently, you have two ways of identifying a path. Either you provide the source connection ID sequence number you see, or you provide the destination connection ID used by the peer on the path.
Okay, so the path abandoned kills both directions then. Okay. So if that's the case, why don't you just use the CID that is controlled by host A, and then you don't have this race condition?
Yeah.
I mean, it seems like a simple solution.
Ian?
Martin's suggestion seems reasonable. I was going to suggest something different, but I think was also workable. But you could just use the ID that initiated the path, that like initially created it. And so then even if you change the path ID on every single packet, like that would be stable over the lifetime of the connection. So I don't know. I think there are solutions here to fix this problem. I think it is a problem. I think you need to do something. But I think probably either of the two things.
Yeah, we can just.
Okay, I think that probably that will wrap it up. But it sounds like there was a lot of feedback on this. So, yeah.
Okay, and I only have one last slide for wrap up, but
where is
slide
that?
12.
12, okay.
But it's just very quick, just to say that actually, given the last update, yeah, we have to then remove the single packet number space text. But for the multiple packet number space, it starts being stable, and we start having some implementation supporting multipass QUIC, and so we should just continue to finalize the open issue and start doing some interrupt testing to assess whether multipass QUIC is ready for further steps. And I leave the floor then to the following.
Thank you. Thank you so much.
Ian Sweat, Google. My slide Ls were very busy and conveniently constructed slides for me. First slide.
Hold on a second. Okay. I had to reload. We had to reload because the slides were made just in time, you could say.
It's quite a short update. It's largely just what happened since Philadelphia.
I don't see that. Do you see that? It's like crazy. Can you do it? Bizarre. Oh boy. Let's see if I can do it.
Can someone else present them? Martin, do you want to try?
We're having slight me echo problems.
Oh, okay.
Let's see if I can do the.
Oh.
Yeah, that's not going to work.
Okay. Well.
Well, do you want to talk for a second?
Yeah, sure, I can talk.
You just
Okay.
keep
So
talking.
two things happened. We removed ignore CE because the use case for it was unclear, and there were an increasingly numerous number of concerns about cases in which it might or might not be dangerous. And basically, at some point, we determined that the value was low and the risk was relatively high, and just ditching it was the simplest thing to do. So there was consensus in the room last time to do that. That has been done. I still am working on the PR to change ignore reordering to reordering threshold, which is a slightly more complex change. I need to go back and update that PR based on the feedback I've received. I would encourage people to look at that PR maybe a little bit later in the week so I can at least integrate the feedback I haven't integrated yet. And then once that's done, in theory, it should be, the draft should be in good shape except for some editorial issues that have come up since Philadelphia. Oh, but now we have visuals. Okay. Maybe go to the second slide if you can pull that off. Okay. So I tried to visualize kind of the 6 bits of reserve plus the ignore C bit plus ignore order are all going to one 8-bit reordering threshold field, which again is an unsigned integer that indicates how out of order packets can be before an immediate ACK is sent by the receiver. Next slide. This pretty much summarizes what I've verbally said, but there are links to the PR as well as the issue. And the final slide, which regales the fact that, yes, I need to update my PR, and then everyone should take another look at it. I think that's it.
Okay, I myself am in the queue, not as a chair. Is there any reason that the reordering threshold should not just be a varant rather than 8? Because
it's a great question. I have no good reason.
Okay.
Would people like it to be a varant?
Oh, here we go. Now we got people excited. Jana.
No, I'm super supportive of that. Varant.
Okay, Gory.
How big a number do you think the IETF RFCs would allow currently, as specified in the BCPs?
I mean, it would be 2 to the 62 minus 1, right?
It's a lot of packets.
I mean, I'm not.
Yeah, I'm not sure that's consistent with any of the other RFCs we've published.
Well, do any other RFCs allow you to? We don't really have a reordering threshold in any other RFC, so.
It's very difficult. It's very difficult for me to decide on what maximum number to disallow, and so I'm not sure. I mean, we could put some text that basically says, as a receiver, like if it's, we already have text that basically says you should acknowledge at least 1 per RTT and like some other things as backstops. So I guess I don't know how to move forward with a max value is the challenge. It's hard for me to reason about.
It sounds a little bit like you're redesigning the transport recommendations in the quick working group rather than the other way around. So I'm not entirely sure what number should be there, but I think the big number isn't the right number.
Well, I would say that whether it should be a varant and whether it should be allowably huge are slightly separate, right? You could have it be a varant and still say, and don't set it big, right? Those are separate questions.
Sure. I mean, I can't argue on data representation, but I could argue on why we might need such a big number and have it a possibility.
I'm going to add, like, say we put a max of 1,000, just as throwing a number there. I don't know if that's the right number. Just like at some point, you know, the C wind dominates, and if the congestion window of the pier is less than whatever reordering value number you put, the reordering value basically stops mattering because the time thresholds and the backstops and the draft start like basically like fixing things, and like you know those are the things that are actually operating the mechanism. So that's why it's so difficult for me to kind of reason about like what max value even makes sense, because even a value like 100 might be so enormous that basically like the other things start kicking in, and it's basically equivalent to ignore order.
Yeah, 100 is ridiculously large.
Jana?
Three things. One, we do not know what is large, and I agree with that. So I think that large BDP, we know from past knowledge that generally large BDP networks carry a lot of packets, a lot of data, a lot of sequence numbers, and we want to allow for large numbers to exist. That's one. Second, we learned through the quick experience that as soon as we moved things to warrant, life became easy. So whether we actually recommend a limit or not, having this as a warrant makes sense because it gives us the flexibility of not changing the protocol, but changing recommendations based on experience.
Yeah.
That's a huge improvement. And number three, again, I don't think that we understand what number here makes sense as a limit. So we should allow for the experimentation, and that's where I would go with it.
There was actually a reason why I stuck any bit number in there originally, and that's because my understanding of the TCP implementation in the Linux kernel is that it uses a UN8 as the like adaptive reordering threshold, and so 0 to 255 is, you know, it's the same range that Linux. But I mean,
yeah, but that's
like that's merely like copying one status quo into another one.
And to be very clear, that's the Linux implementation of TCP, right? It's not a protocol. So I think there's a difference there. They can change that whenever they want to.
Yep.
It's harder to do that with a protocol.
Maria?
Yeah, so like I don't think an absolute number makes sense, because like the one assumption that is written in an RFC is that like TCP rec assumes that reordering happens within one RTT, within one window basically, and like this window like doesn't have a max value, right? So like we don't know what will happen in future. I don't think we should have a max value, but maybe there might be additional considerations that we want to write down at some point, but it shouldn't be a number.
Thank you everyone for the feedback.
Great. Different question. How near do you think you are to being finished if we can deal with these little things?
I mean, this is the last PR that's actually substantive. Everything else is editorial. But it doesn't. There is editorial work to do because people kind of keep throwing on minor issues. But yeah, it's pretty much done.
Gori preempted my question. I was about to say, how soon do you think we're off WGLC?
I mean, if I'm focused this week, we can get through all the real stuff, and then.
Okay, that sounds good. Yeah,
it's just a matter of, yeah.
Thank you.
You're welcome.
Jana?
I was just going to add that I think we can, if we could plan to go to whatever the next step is. Is that last call? Is that the next step?
That would be the next step.
So the next month, we would love. Yeah.
Well, why don't we plan on that, and then I will shoot for that. Okay. And then I will I'll change it to a varant either way, and then we can discuss on the issue or in the PR. Okay. Thank you.
Stop your nonsense. We can try to go back to.
We now have to figure out how to stop the screen share.
All right. Is Q on?
Robin is going to come up and talk about QLog, the X-Files update.
Yeah. Right. Yay, QLog. Woo! All right. Next slide, please. As you might have noticed, we have a new editor on the team. It's a very mysterious figure. We don't actually know his name yet. We only know him as the quick hat wearing man. And he was so gentle to us today to be the first meeting, I think, in ages that he hasn't actually worn his quick hat. Thank you, mysterious man. But so under, no, previous. under his guidance, we have made quite some progress this time. A lot of it editorial as well, which you can nicely follow in the change logs in our 3 different QLog documents, which you can also find on the bottom of the slide. There are, however, a few things that I wanted to bring to the working group today, obviously. Next slide, please. The main one, an open standing issue for a very long time, is about security and privacy considerations. Last time when I presented, we had this plan of going full out on all of this, to have very extensive guidance on an even per field basis to do, what is sensitive data and how should you log it if you're worried about that kind of stuff. It turns out this is a very complex issue. Who knew? It also turns out that there's relatively little practical guidance on this in the IETF, at least not when it comes to logging. There, and then in discussion with some people who know a lot more about this than I do, that things like anonymization have long been shown to not be enough to actually protect against a lot of different risks in this. Another important part is that doing this right inside of QLog would substantially delay the QLog documents even more than they already have been. So the new approach, next slide please, is to do things a bit more simply, to have only a relatively basic guidance within the QLog documents that primarily says there are risks, these are some of the risks, and here are some practical examples of where in the QLog there might be sensitive data without having to actually list everything in there. And then also have some tips or general ideas about how to manage that risk without going into unnecessary detail. In parallel to that, however, it would be good, I think, I've talked to a few people about that who seem to agree, that it would be useful to have a parallel effort in the IETF discussing this problem in more general terms, cross QLog, beyond QLog, I should say. How do we give privacy guidelines for logs in particular? We have some stuff on the protocols themselves, for example, linked on the slide, RC6973, I find very interesting. Maybe we should have something like that for logs here as well. Maybe, maybe not. That is still very much TBD. If you're interested in that, please come talk to me. We will see what we can do. So that not, but for the first part, so the QLog specific part, we now have some very specific text already in the document. Next slide, please. I think we have some very good guidelines in there at this point. I'm particularly a fan of recommending to store all the QLogs in a blockchain. This means we can use smart contracts to make sure everything is privacy sensitive and secure. So I think that part is relatively mature, but there might be other sections in the privacy and security considerations that might need a few more eyes to look on. So if you want, please take a look at the current section in there and let us know what you think. Here on the list, on one of the issues, I think this is one of the big ones that we really need some more eyes on. Now that everybody's awake after I mentioned the word blockchain, next slide. Another somewhat important issue is extensibility. So we will have some basic QLog documents first, but then the idea is that we will extend these to include, for example, quick and H3 extensions, but also new protocols down the line. And normally that wouldn't be much of a problem. The way we typically do that, I think, is simply have some pros in the new documents that might update something that we had before. With QLog, it's slightly more difficult because we have this CDDL thing, so a bit of a strongly typed definition of what we're doing in the schema. And the ideal point would be that we have that you could basically have the basic documents and whatever extensions you have, extract the CDDL from all of them, merge them together into one big pile, and then have that be valid and strongly typed CDDL there. That would be the dream goal, right? And CDDL has some extension capabilities, some of which, as you can see on the slide, we already use within the main documents as well to link the main schema and the event definitions there. But still, we wanted to exercise this to see if we hadn't forgotten anything. Next slide. So I took some notes from some of my fellow Quick and H3 enthusiasts and defined a datagram extension document. So for the 2 different datagram RFCs, but this time for QLog events for them. This is a separate draft on my personal repo. I'm not trying to get this adopted anywhere or anything like that. It was just a way for us to see if there is anything missing in QLog to make this possible. Turns out there is, or there was. We fixed some of that in the last update as well. Specifically the ability to add new frames that was missing. But then it also turns out we need to define new transport parameters to negotiate this, we need a new H3 setting to be able to enable this. And we also want this in QLog. Seems simple enough. Just add those to the QLog specs as well. That's fine. But then the question is, where does that end, right? Because there might be other ways that you want to extend. You want to add one new field to an existing event, for example. If you want to do that for all of the different QLog events, well, then everything needs to become an extension point, right? And it's definitely an option. Is it the best option? I'm not sure. So next slide. I try to look at how other things within this atmosphere are doing it. I'd hope to find some inspiration in the multipath draft. And maybe I did, maybe I didn't, I don't really know. So what they basically do is redefine the ACK frame, right? They copy over whatever was in there, I think, and then add some of the stuff that they want, which is a valid approach, but you can see how that could get conflicts with other future extensions that try to do the same thing. So do we want to do the same approach for QLog or not? Is it a pipe dream to have everything in CDDL and to be able to just extract the CDDL and have everything match nicely? Or will you expect people to do some manual labor for these things as well? It's somewhat unclear to me at this point. We would say people who have an interest in this or experience with this especially, let us know what a generally good approach for that is. Otherwise, we'll probably just go with whatever isn't clear extension point within Quick and H3, that will be in QLog as well, and everything else will be solved afterwards. I'm not sure if you want to take questions now or later.
Miri, do you want to wait till the end, or do you want to go now? It's kind of up to you, Robin.
It's all fine. I don't have too much more anyway. Right. Next slide. The other big thing is QPAC. QPAC currently, we basically just have like a wire image copied into QLog, which is somewhat useful if you're doing low-level debugging, but we would like some higher-level events in there as well that are actually interpretable by people who don't know the innards of QPAC, including me. So very practically, I would like to have a simple head-of-line blocked event or something similar like that, not necessarily this, that just tells you, okay, this is where QPAC was having problems on this stream because things were delayed. That would help a lot. We don't have that currently, and we are slowly starting work towards that. So people who have experience with QPAC or maybe HPAC even, that have experience in practically debugging this and knowing what would be useful in terms of high-level events, please let us know. And then the second thing about QPAC, next slide, please, is that currently QPAC and H3 are in the same QLog document, which kind of makes sense because they kind of belong together, but they are separate RFCs. And it would make a lot more sense editorially for us to split them up as well. So I kind of really wanted to have like a bike sheddable issue here today as well. So this is it. We can discuss this for half an hour down there. So that's one of the things. If we don't get particularly strong opposition, we'll probably just separate them out. We will then go from 3 to 4 main QLog documents at this point. Final slide, or almost final slide. We have some remaining design issues open. I think for most of them, we have a clear idea of what we want to do with them, and we plan to do it by next update there as well. One of the main exceptions there is a multipath discussion. So I don't think we want to go full out on multipath in the base documents yet, or anytime. The question really is, do we want to have something for basic multipath logging in there? There's been a long-standing issue of adding something like called a path ID to each individual event that allow some logging or some coupling of things there. That would also potentially be useful for connection migration within non-multipath logging there as well. But really, we in the editors currently have almost no experience with either connection migration or multipath, especially not debugging these things. So people who have experience with that, I'm looking in that general direction, gentlemen. Please let us know what would be a good approach that you think. Final slide. To give people a little bit more incentive to collaborate, to speak up, I've actually brought some very delicious Belgian chocolates. So everyone who comes to the mic or who answers on an issue or helps us this week can come to me and get some Belgian chocolate. I originally wanted to do this about a year and a half ago. It's just one. I don't have a pack for everyone. No, I originally wanted to do this a year and a half ago to thank you all for helping me get my PhD with all the QLOC stuff. COVID happened, obviously. This is the first time I see you all. So basically, anyone who thinks they've helped me with all this stuff throughout the years, which is probably most of the people in this room, thank you. So most of you are also eligible for chocolate. So come find me afterwards. Thank you.
With that, Mary, do you want to say your piece?
Yeah, can I have one chocolate per question because I have multiple ones. So question number one, which blockchain? So you're saying Datagram is not part of the QLOC format currently?
At this point, no. We're making kind of the approach that everything that is not in the core RFCs will be an extra QLOC document as well.
So I mean, that might also answer a question about QPAC, but I think that's kind of silly. I mean, Datagram is like a small extension. It's like widely deployed. Why don't you put it in this document?
I'm sorry, I didn't quite get that.
I'm not sure if that's the right approach because like then we publish like for like the Datagram part you need for QLOC is pretty small, I guess. And then publishing an own RFC for all these things, kind of a lot of overhead. I don't think that makes sense.
We've discussed this at length, and there are several examples historically within the IETF that has been done for similar things, apparently. And that's also, I think, the preferred approach that Lucas was suggesting, to just have indeed small incremental QLOC RFCs for small incremental new events. But we can discuss that, but that's the current way we're thinking about it.
Yeah, just to step in here, what we're trying to avoid, so the QLOC editors have been working hard and appreciate their input, but we're kind of stalling because there's a huge backlog of issues of things, and as we're trying to figure out our own decisions related to things like CDDL, etc. Meanwhile, the QUIC working group and everybody else using QUIC is marching on and adding all of these other things. So if we try and incorporate everything that's ever been defined, like it's just going to stretch out our timelines. So it becomes, what is a good demarcation to draw? We started off with this being the schema for QUIC events and HTTP3, and Datagram didn't really exist like in its final form at that stage. We could just sneak it in, but then when we look back in time, we would need to justify why we did it for Datagram and nothing else. If you're implementing Datagram, there's a strong possibility you're trying to use it for stuff like mask or web transport, in which case you also want the HTTP3 event. I wouldn't suggest you need 2 RFCs for that, but if you're going to create a document for events related to datagrams, and it's not just the wire format here, it's other events that you might want to do, such as I dropped my datagram on the floor because you know, I have a queuing buffering model and it overflowed locally. We can model non-wire things here. So yes, there's process and overhead to every RFC, but yeah, we could encourage people to try and define QLOG as part of the new extensions that they're doing. I don't quite know. I'm really happy to hear input here, but it doesn't seem right that we're going to try and lump everything into the drafts that we have adopted into this working group. That seems like it's just going to stretch everything out to me.
Yeah, and that was definitely not my proposal, but I think we also don't need to really be religious about this, right? So like, I think Datagram is a proposal or is like an extension that is actually widely deployed. Most stacks have it in there, and it's a really small extension also. And then having an own RxC is a lot of overhead. I think we can just like take a practical approach and like go as we think it makes kind of sense. I don't think we have to have strict rules about this because you can always write a new RFC that just adds additional features. So I think that we should just take the stuff that we think is important right now based on a kind of deployment level, and it's actually not important to get it like absolutely right, but it's important to limit the overhead here, I think.
Quentin?
Yeah, Quentin de Koning.
I had a second question. Do you want to go on this part?
About the pass ID.
Yeah, so you're saying the same thing I was wanted to.
Okay. Just first a clarification question. In QLOC, is there a way to indicate which connection ID you are using in a packet or not? So let's say I send a packet. Do you have information saying it was this connection ID?
Yes, if you log the packet header.
Okay. So in that case, maybe the pass ID could be an identifier just for a for tuple. And for me, I would be happy for multipass.
For you, it would be?
I would be happy with a plain identifier for identifying a for tuple.
Okay, but you still think it should be in the base draft?
I think if it makes it easier in the end, but in any case, if you want to track migration, you need at some point to know that the IP or the port change.
Mm-hmm.
So that's it.
Jonathan?
Yeah, Jonathan Lennox. I was going to say, my inclination would be to say that the QLog spec should cover all extensions published before it goes to publication, but publications afterwards should define it themselves. Basically, have a section in the draft saying how to use this, how to describe this extension in QLog. I mean, I guess the question is writing that section, is it more important to have a deep understanding of QLog or more important to have a deep understanding of your extension? My guess would be the latter, at which point it'd make more sense to have in the document where the people who are working on that extension know exactly what information needs to go in it.
Mm-hmm. Mm-hmm.
So I would say just recommend that all future quick extensions should, for whatever should means for writing a document, define how they're used with QLog.
Okay.
Martin Duke, Google. +1 on like encouraging future draft authors to have a little like QLog section if it's applicable. And actually, I agree with Miriam more than I would say that. I think the principle of of not trying to keep up with everything happening in the working group is sound because you will never finish otherwise. But it is. I also think it's not necessary to be religious about this. So I don't particularly have a dog in the datagram fight in particular. But if I wouldn't, I would encourage you to be willing to take that in if you think it's important. And if it's not, and if not, like to cut it loose, and we can do a follow-up draft to roll up other things, or not everything needs to be Q-logged potentially if nobody cares enough to write it up. So I think that's okay as well. Let's not be religious about what goes in this versus a future draft versus never being documented at all. But yeah, let's finish. So let's not try to race to publication to include everything up to publication.
David
Skenazy, chocolate enthusiast. So I'm going to agree and disagree with Martin at the same time. So first off, I think, Lucas, you're underestimating the cost of publishing an RFC, not only in terms of the author's time, but also our wonderful, lovely ADs having to click buttons on every one of them, and the surprisingly high amount of money going to the RFC editor per page. So I would strongly advise to reduce the number of RFCs, like save everyone a lot of time. Then on that note, agree, like, let's not keep this open forever because there was always something more. Just pick a date, like say today, and say, okay, everything that's published today, like datagram, we put it in. Everything that's not published today, we don't put it in. Done. And then for future things, they can decide as needed. We don't need to mandate this. Please, 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 dear IESG, let's not have a repeat of the Yang thing where we have an AD asking everyone to put QLog in their document. So we can do that, but let's not be prescriptive. Just publish a document and move on. I'm going to come grab a chocolate now.
Yeah, other people can also come.
Yeah, feel free to take your claimed chocolate. Christian.
We almost had consensus on the chat that what we want is something like publish a draft now, have a wiki in which we list all the updates that come in and all the experiments that people are doing, and have something like a yearly update that summarize everything that has been done since that year. That seems like the right compromise. I know, Robin, it's bad for you because, I mean, if you get to publish one RFC for each update to QLog, your resume gets much bigger. But hey, we have to make compromise. Specifically on the point of pass ID, the reason I raised that is that when I was doing the early experiment with multiple sequence number and pass number, sequence number per pass, then the visualization using the existing tool was completely weird. I mean, you will have arrows going in every which direction, or the tools will be broken and all that. So I think that in the case of multipass, we probably need to have some kind of experimentation first about what the tools need in order to properly visualize the multipass, what's happening on multipass, like multiple lines for the congestion controls and things like that. And if we don't do that experimentation, then specifying just a number, it's nice, but it's not that useful.
Okay, makes sense.
Yeah, I just kind of want to second that point. Like, we've been looking into that as well because we're implementing multipass and you need some logging and whatever. And it wasn't clear what's the best way to extend it because you always need the pass identifier with like most of the events that you have in there and so on. So like there are different ways to do that. That would be nice exercise to actually get that first, like get one solution that makes sense before we wrap this up completely for multipath.
Okay, I think that concludes. Thank you, Robin. And remember, he has chocolate. And now, Martin, should talk about quick. Yeah. Now, Martin is going to regale us with the exciting new developments from QuickLB.
No, I'll wait. I won't subject you to that. This, I think, would be pretty quick. Not much has happened. We did get another crypto review of the 4-pass algorithm, which was the only contentious bit of the crypto. And we did a little tweak based on that. You can see the pull. It's already committed, but if you have a problem with it, we can always change it. I've added a lot of non-normative text about security analysis and just some deployment tips that have already come up from like our further design on some details at Google. I'm reading some crypto papers right now. I don't anticipate any changes. And again, the wheels are turning at deploying. So when last we met, the conclusion was we could just sort of sit on this until somebody had actually deployed it, which is what I'm working on. Like I would say that possibly by Yokohama, certainly by San Francisco, we should have that done, and this should be out in the world. And I don't know, is there anything the working group is looking for specifically as a report, or just the fact that we did it and it is possible to do?
I think that's mostly what we're looking for, since as far as I know, no one else has expressed an interest in deploying it yet. So, yeah.
Okay. I'm open for any other questions, Ian?
Or commentary, as it may be.
Ian Sweat, Google. Martin, did you want to go into the multi-threaded server silo issue in more detail, or?
Yeah, I could, sure.
I think it might be worth just like floating that and seeing like whether that's a shared problem.
Yeah, so there's a non-normative section in the draft now that has been growing over the last couple of versions, and it's about sort of the multi-threaded problem. Like, most of us operate servers with multiple threads, and as you change connection, it has to be routed somehow. And depending on your architecture, you may not be able. So there's a number of solutions to this, and the section is non-normative because this is not really a server load balancer thing. This is a kind of server talking to itself thing. One solution is to treat it like a layer 4 load balancer and have whatever's doing the demultiplexing decrypt the connection ID, have some part of the server ID define what thread it's going to. That's a completely viable thing that will work in some architectures. In some architectures, like for instance Envoy, which is near to our hearts, uses BPF, and you're not going to do AES ECB in BPF unless you're much cleverer than me. So there's some other alternatives, and it just talks through those. One is for, again, since you're all kind of on the same device, the thread can actually sort of register with the demultiplexer. Here's a connection ID. Here are all the connection IDs that route to me. So just have a big table. we have a fairly interesting solution, I think, that is kind of matches the pattern of quick header encryption, where basically you have a big pile of ciphertext, so you apply like a keyed hash to that ciphertext, which generates a bit mask, which then you apply to a thread encoding that's somewhere in the sort of the non-ciphertext part of the connection ID. Certainly in comments, and he brainstorms other ways to accomplish this problem. Again, I don't think it needs to be standardized because it's the server implementation issue, but it would be nice for that to be A, clear editorially, and B, have as many good ideas in it as possible. So I invite you to take a look at that. Other questions or comments? Thank you.
Thank you, Martin. So I think now we are moving on to our as time permits, and we have Martin Seaman to talk about the reliable stream reset draft.
Next slide, please. So what happens in QUIC when you reset a stream? You send your data in stream frames, and then you send a reset stream frame containing that.
Yeah, maybe raise it up because you're big.
Can't hear me?
Yes. There you
Okay,
go.
is that better? Okay. So in QUIC, you send the stream data in stream frames, and then when you want to reset the stream, you send a reset stream frame that contains the ID of that stream. So in the best case, all frames are received by the receiver, but packets get lost, and stream frames may not be transmitted to the receiver. So when you have reset the stream, you've already declared like you're not interested in this data arriving anymore, so you wouldn't do any retransmissions for stream frames that have been lost. On the receiver side, the receiver knows that stream frames will not be delivered anymore, so it typically won't wait for stream data to arrive. But as soon as it receives the reset stream frame, it will tell the application here, oh, the stream is dead. The peer reset it. Next slide. So this can lead to certain problems if depending on how you use the stream. So a very common pattern in applications is to open a new stream and then to put some kind of stream identifier in the beginning. Like, so this is not the QUIC stream ID. This is like an application layer identifier that you put in the stream. For example, in web transport, you can have multiple web transport sessions on the same QUIC connection. So the first thing you send on a new stream is basically it's an HTTP frame that contains a session ID, and that allows the receiver to then say like, oh, this stream belongs to the first web transport session, and this stream belongs to the second web transport session. There are other use cases where you can also have some kind of application layer message that might have like a header and a body part, and yeah, so this is a very common pattern to build applications on top of QUIC. Next slide. So the problem here is when the stream is reset. Previous slide, please. Sorry. When the stream is reset, and these and this is all in flight. Both the identifier and the stream data are lost, and both of them are not retransmitted. So the receiver of the stream might end up in a situation where it receives a reset stream frame, but no stream frames for that stream at all, and it won't know what the identifier of that stream was. Next slide. So to solve this problem, I've written up a draft that introduces a new frame at the QUIC layer, a so-called reliable reset stream frame, and this is just a reset stream frame with one additional field with a reliable size, which is a variant. So what exactly does it do? Next slide. So basically, it tells you, well, this is the stream. The stream is being reset. We have the final sizes in the reset stream frame, but we have this orange part, and this is the reliable part of the stream. And as a sender of the reliable reset stream frame, I guarantee that I will retransmit and retransmit all the data up to the reliable size. After that, no guarantees. As the receiver of a reliable reset stream frame, I can then know that I can deliver all these bytes, all the bytes up to reliable size to the application, and I can then surface the error, the stream reset error. Next slide. So I'd like to point out this is the reset stream frame is just a degenerate reliable reset stream frame where the reliable size is exactly 0. Next slide. So as I said, as a sender of the frame, you guarantee that you retransmit everything after up to the reliable size, and as a receiver of this frame, you guarantee to your application that you deliver that many bytes, and only after that surface the error from the stream reset. Next slide. I know this sounds scary because you have to change the quick state machine, the quick stream state machine, and the quick stream state machine is not the easiest one out there. I implemented this at the hackathon. It is not as scary as it sounds. So you can see it was about 400 lines of code added to my implementation, of which 300 were tests and just 100 actual code. So it is doable. Next slide. Yeah, that brings me to the end of my presentation. I would like to hear your thoughts about this draft.
So I'm going to jump Jana, not as a chair, but as a quick stream enthusiast. As someone who has written some of the code that introduced bugs and then subsequently had to fix them around resets of quick streams, I would rather not complicate it more than it already is. And 114 lines is 114 lines more opportunities for bugs that are potentially catastrophic. And so I was wondering, I made this suggestion on the list, which was that instead of having this, what if we had a reset that had semantic application data in it, which is to say, hey, I'm resetting this stream and this is some application relevant information such as a stream identifier that can be communicated to the app layer, and then it will know what kind of stream it is identifying as being reset. And then you would have to not change anything about the quick stream state machine. Jana.
Thanks, Matt. Thanks for the presentation, Martin. I think that the semantics of what stream and stream reset have been pretty clear, right? In the sense that the stream is basically, you think of it as an object, it's a semantic that you use for something like that. And then at some point when you want to actually reset the stream, you don't have to reset the stream, you could send a fin. And you could actually, fully reliably deliver the entire stream content before you discard any other applications that you want to. And this allows for a certain degree of freedom, which I have to say that the complexity of doing this work, not just in terms of the protocol implementation, but in terms of thinking about and in some ways there's a purity to the stream reset that this sort of eats into, right? And that has very, very clear to me complicated. It creates complications or ramifications down the line. I'm not sure that I'm convinced that there's a lot of value for the complexity that this introduces. So I'm not convinced about the use cases. That's what I'd say. And I'm not convinced that the uses cannot be solved in other simpler ways.
I would be happy to discuss other solutions because this is a problem that comes up in web transport. That's a problem that comes up in other applications that are built on top of Quick. And it seems like they all run into the same problem, and they would all need to build, if we don't have this or something like this, they all need to build something at the application layer to solve this problem, which seems like fundamentally the wrong layer to solve.
Well, so the question from my point of view
So,
would be,
maybe if I can comment on your point, you can just fin the stream and have it delivered reliably. I don't think this works in most cases. So first of all, like if there's application level semantics about finning and resetting. Like if I reset, I know that the thing I sent is not complete. If I fin it, then I'm telling the peer that what I sent is complete. So basically, your suggestion only works if I upload, if I complete the transfer, and I might have uploaded like a 1 GB file, and I really want to stop doing that without losing that, I don't know, 5-byte identifier that I put at the beginning of the stream.
okay, so I would argue that maybe there's a mapping problem here. That part of it is that the application wants to reset stuff. And the second piece is that the protocol mapping of the application state into what you're doing with streams is broken, because you're trying to convey both. You want to convey reliably this particular mapping, but you don't have a way of separately conveying application intent for resetting the stream. So to me, that is basically two separate problems, and you're conflating them by putting them on a single stream. I don't want to design on the fly here.
Yeah,
that's what I'm doing. I know that, but I think that this can be done differently.
Yeah, just as a chair interrupt, we're short on time. So if you're in the queue, come up, but please keep it quick. I need chocolate. Yes, that's me. Oh yes, I'll keep it quick. Just as we talked through this, I've seen the proposal on the list, but I'm just like, I think H3 kind of has these problems already, because there's a lot of rules around. You must create a control stream, but you must not close one. But there's probably some race condition that could happen. We seem to live with it okay, but I don't know if anyone's really probed this area of the H3 protocol. So maybe there's space for a solution. If it is a problem, maybe it's not this one. I don't have a strong opinion.
Mike Bishop, HTTP3 editor, and I can comment on that actually. One of the changes that we took really exceptionally late in the process to the H3 spec was on some of the unidirectional streams saying, hey, as a receiver, it would be a really bad idea to reset the stream until you've read the first however many bytes to know what the stream ID is, or the push ID in that case, I think. And this is basically solving the same problem from the send side. And yeah, it's a problem that exists. It's one that we can kind of live with by leaking identifiers and reclaiming them. But it would be nice not to leak the identifier. So I would support this work.
David.
David Skenazy, web transport enthusiast and chair, but speaking in my personal capacity here. I haven't really seen this problem in practice for the like H3 side of things, because like I get how this can happen in theory. In practice, like why does your implementation go around resetting streams willy-nilly? Like, doctor, it hurts when I poke myself in the eye. Don't do that. The only real problem that we've seen is the one in web transport, where because the streams get reset, which is something that the application can do. So at Quick, we don't control that. But then we miss the accounting, which is a Quick layer thing. So that happens because of the separation we have of entities between the like JavaScript in the browser and the Quick stack. I see the solution like that's been proposed in web transport as using a capsule as being much simpler. And like I, as chair, want web transport to get done as quickly as possible. So let's not do something too complicated. I was initially saying like really, let's not do this. Let's instead just solve something at web transport. I would be maybe open to something that I think Jana proposed, which was a much simpler version of this, which is like, yeah, in that reliable reset frame, you can put the start of the stream, and that definitely reduces the amount you can send. But in practice, we're only ever going to want to send like 2 variants tops, maybe 3. So I think that might be a much simpler solution, and then I'd be okay because I think we could get that out the door in a quicker time frame. Thanks.
Just to quickly interrupt, does that feel like the kind of work that should be done in this group? Is there any objection to that? No, great, thanks.
So maybe to the web transport capsule, I don't agree that this is the simplest solution. I have slides for that for the web transport session.
Yeah, we could
I
talk
think
about
it
that.
creates a lot of complexity if you really think about the corner cases. But I think the web transport working group would be the more appropriate place to talk about those.
So if I may propose, speaking now as Web Transport Chair, we're going to discuss this in Web Transport. So if people care about this topic, please come to the meeting I'm chairing that I don't remember when it is. And we'll discuss then. And then based on what the consensus in the room seems there, I think that'll be useful input here. Because if Web Transport says, all right, we're going to ask Quick to fix this, it's a different story that we're fixing it in-house. So please come to Web Transport.
Okay, and with that, we have one more as time permits. It's about FEC in Quick. And thank you, Martin.
So, hello everyone. I am François Michel. I am doing a PhD at UC Louvain, and I'll discuss the FEC extension for Quick. Next slide. So, although there are a lot of reliability mechanisms in the lower layers, we can still see a lot of losses at the transport layer. So the graph at the left is a cumulative distributed function I plotted from measurement lab speed tests about the loss rates that people see when they do speed tests, and there are still quite high loss rates. On the right, this is a table that I computed of loss rates that I saw on my Starlink access. So we can still see that there are some losses and that it impacts the app's responsiveness, because with Quick, the lost data are retransmitted. Next slide. So there's the FEC mechanism that can be used to reduce the impact on the responsiveness. The idea is simple. If you want to send 3 data, for instance, you can send a redundant packet so that if you receive at least 2 data and the redundant packet, you can reconstruct the lost data. Next slide. So there was already a lot of research that has been done with Quick and FEC. We did some of them. But most of them were only focusing on emulated and simulated losses, except the original Quick paper. But the original Quick paper used a XOR error correcting code. So the idea is that it was not able to handle correlated losses, aka loss bursts. So after all this works with research, we started to think that it might be the time to reconsider the use of FEC in Quick with real networks, basically. Next slide. So we did some experiments recently. We implemented an FEC extension on an efficient implementation, Cloudflare cache implementation. We did some experiments with HTTP download and uploads. And we saw that with that table. We did downloads of 50 kilobytes files. And in global, we saw that there is no harm when there is no loss. But when there are losses during the download, we saw that we could improve the download completion time quite importantly, especially when there are losses in the end of the download. There's a question. Yep.
Yes, clarifying question. Just when you say in the transfers that had losses, were they induced by you, or were they just, you noticed at the end of connection, you noticed that some of them had losses and some of them didn't?
So can you repeat?
So your measurement, the columns on your table have transfers with losses and transfers without. Where did this loss come from? Did you induce the loss or did it just happen?
No, so they just happened. So we did some downloads over Starlink. We did not induce any loss by ourselves. We just did simple downloads without any netem or anything.
Thank you.
So there's another question.
Spent there.
Spencer Dawkins. I just wanted to thank you for bringing this work forward. Multipath QUIC and FEC for QUIC were two things that were in the original charter that we did not do while we were working on the core QUIC specification because we wanted to finish the core QUIC specification. So I'm really glad to see this resurface. And I would appreciate it if people of the working group could tell you if they think this is a bad idea, because it seemed obvious to a bunch of people early on that it would be useful.
So thank you.
Did you want to finish up your slides? I think.
So yeah. So basically, we designed a draft explaining a lot of stuff. We are able to negotiate the error correcting code and stuff. We must select carefully the error correcting code. Next slide, because there are RPR stuff. The most well-known codes are under patents that are still active, and there are old codes that work well, but that are not under patents, but they are a bit less efficient. Next slide. But finally, we searched a bit and we found a good candidate, which is called Tetris, that was developed in the Network Coding Research Group, aka the French Mafia. But basically, these are Fontaine's code. There is no IPR disclosure, and it's described as patent-free. Next slide. So if you want to help us and take part of in this process, don't hesitate to discuss the draft in the mailing list. If you want to use Tetris, we have an implementation. It's not open source yet, but the idea is to have it open source and free totally. So if you want to use it, send us an email. We can send it add you into the repo. So thank you.
Jana?
Jana Iyengar, thank you for the presentation. FEC and QUIC have a long and colored history, so to speak. And I'm not sure what the future holds either. But what I'll say is that there's the particular mechanism that you're talking about, which is to do an FEC frame or packet at the end of the transfer. When you say the end of the transfer, do you mean in sort of a quiescence time when you have nothing to send and you're waiting for the next request to be received? Is that the period of time you're talking about?
Yeah, so when we send the repair frame at the end of the transport, basically here in our implementation, if we have no user data to send, so no stream data on datagram, then we send a repair frame.
Nice. Okay, so that's cool. There is another technique or another thing that you could try there, and I would recommend that you try it as well as a reference, is not do FEC, but just simply proactively do some retransmissions. Because at that point in time, typically you will have only one window of packets or a partial window of packets outstanding on the network. And that is all that matters, right? Because everything before that is typically acknowledged and has been received by the receiver. And at this point, you're only looking at a partial window of data that you need to send. You could just as well retransmit some of those. If you have space in the congestion window to send more, instead of just sending one FEC packet, you can send out a few retransmissions if that's what you would like to do. And if you were using our stack quickly, I would tell you to just turn this on because we already have implemented that. But that's something to look at as an alternative reference here.
Yeah, sure. And PyCoQuic also does this thing, retransmitting the last packets. So it's a specific case of FEC. Basically, it's not coding the packet.
Speaking of PicoQuick, Christian, do you want to add something quickly since we're almost out of time?
Yeah, I mean, just to say that it's a great idea. I have done a lot of simulation of the use of FEC after the download in a satellite link. I was not using FEC, I was just actually repeating all the last window of packets, which is 4 months implementation. It does help on a number of use cases, and I think it's good work, and we should encourage that. It's clear that having something there is good. What I would like to see are published statistics on the loss patterns of the links that you are using. As in, what's the mean time between errors? What's the how many packets are affected by a stream by errors and things like that? Because whether one of the reasons that the classic FECs don't work well is because we often have bursts. And I would like this kind of thing to be documented somehow.
Yunfei?
Yeah, just I agree with Christian. We are also very interested in the loss interval between packets, or if the loss of packet is bursty or is more random. Because we also tried FEC, and one thing we figured out is that for many link layer technology, they already have, for example, hybrid ARQ. They do retransmission. So what you end up happening is when you do the observation and you find that, okay, if you have loss, the loss is mostly like a bursty loss. But FEC is not very effective in fighting against the bursty loss. And if you want to fight against the bursty loss, you can do is you increase your coding length, but that also increase your decoding complexity.
Martin?
Yeah, can you speak a little bit about why you chose to protect frames? From our perspective, application data is the most important thing to protect here. And the previous efforts, I know Ian's just left, but he was protecting the stream contents rather than the frames themselves, because when we generate a new packet for the same stream data, we don't necessarily put it in the same frame as last time. And while some implementations do effectively just copy frames, most don't. So that seemed to me like a pretty major hurdle. Can you speak about that a bit?
So is the question, why do we protect frames instead of stream content? Yeah, so one of the reasons is to be general and also protect datagram frames or other control frames that might be timely. So that's one of the reasons.
All the control frames have retransmission setups and whatnot, and datagrams are lossy. So I'm not sure that being general in this case is working in your favor.
Yeah, so yeah, we can discuss it after.
Yeah, thanks for your talk. It looks like the path you chose had quite a lot of persistent loss. Your draft says very little about congestion control and how you would choose how much FEC you would apply. Are these areas you're going to work on, or are they areas you don't think should be included in the draft?
We're at time, so if you could take that question offline, I think it's good. Thank you, Gary, for saying it. But yeah, thank you, Francois. Yeah, we should wrap things up here. Thank you, everyone. This is the first meeting Matt and I have sat together in person. We're delighted. We're going to go and consume some chocolates. I do have some stickers at home somewhere in a box. I do not know where they are. Come and find me during the week if I'll find them, and you can have some. But thank you.